In addition to normal functions that I explained in video 6.1, Python also offers the so-called lambda functions. Lambda functions are also known as lambda abstractions or anonymous functions. Let's write a little example that calculates the, the hypotenuse of a triangle. Because it involves calculation, then we will import the module math, and now we will write the function here, the lambda function, and let's call it Pythagoras. And this to define the lambda function, we use the reserved word lambda. Then the arguments that is going to need, in this case just the sides of the triangle, and a semicolon indicates that the body of the function is coming here. And then this will be equal to math dot square root of a squared plus b squared. This is the whole function. Usually lambda function contain a single line. They are a very concise method of writing function. And we can call it here. We will use a print just to see the results on the screen. And then Pythagoras. And then just to make the example very simple, we will use 10 and 10. And we know that they will be the square root of 200, that is about 14, right? And we see that effectively our lambda function has correctly calculated the hypotenuse of our triangle. Let's write now a little bit more complicated lambda function. And this lambda function will generate a list of random mutations. We will need a random number generator, so we will import the module random. And let's say we want to define X number of mutations along the sequence of chromosome 1. So we will need the length of chromosome 1, which I don't remember exactly, but I know it's around 248 millions. So here comes the function itself, and we will call mutations generator. And this will be equal to lambda with a single argument that it says length, and here we will call the random module and the function sample in the range of 1 to length, whatever it is, and the number of mutations we want. Let's say 1000 mutations. Let's go up. Here we will call the functions and store it in a list that will be called mutations. Mutation generator, and here will be chromosome 1 length that we already specified above. And now let's use a for cycle to print the results. For mute in mutations, print mute. We'll execute that, and we see that there is 1000 mutations that we have generated here, and they should in principle be random. Let's write our last example of lambda functions. Let's find here all prime numbers in an interval. Let's call that function simply primes, and that will be equal to defining our lambda function here as always. and we will need the start and the end of the interval. And here comes the meat of the function. It says num4 num in range start to the n plus 1, and this annoying thing already went away. Okay, let me split here the code that you can see better. And now let's set here a conditional. If the quotient, well, first maybe if num is greater than 1 and it is true, which we check with the function all, that the quotient of dividing number by another number is different from 0, because remember that primes are only exactly divisible by themselves and by 1. And let's split here again. Oh, sorry. For I in range, this will be 2 to the num. We close the two parentheses and the square. I believe is correct. So let's try it now. Then it will be primes of 2 to 10. Let's do it easy at the beginning. And yeah, it produces correct results. Let's do it for 1000 now. And again, we see that all the prime numbers from 1 to 997 has been found. So this is what I had to tell you about lambda functions. I hope you find that useful, and I will see you in the next video. Thank you for watching.